Okay, so hi everyone. Sorry about the technical difficulties to begin with, but thank you for having me at OWASP SF. I moved here 9 months ago, so I guess not very fresh anymore, but I've given presentations at OWASP London, so it's nice to be at another OWASP chapter. So just a very quick introduction into who I am. Ignore the spiel, but I work for Synopsys, and ultimately I really enjoy JavaScript. So that's what I'm going to talk to you about today. So let's just set the scene very quickly about the JavaScript landscape in 2019. So when we talk about development practices, a lot has really changed in the last few years. Applications are ultimately being deployed at a rapid rate. JavaScript is literally everywhere. You know, it's on IoT devices, it's on embedded devices, it's in the browser, native applications. It's ultimately everywhere. And obviously there's even compilers that transpile to different from Java to WIT to JavaScript. We're ultimately going from a way where we were once on a 80-20 stack where it was 80% server and now 20% on the client. But now we're at a point where JavaScript has taken over the world and it's more of a probably 50-50 split on the rendering. And we even have a very easy introduction into the full stack space where people who know a little JavaScript can work on the client and the server. So it's kind of crazy where we are today, but there's a Stack Overflow survey that happens every year, and it recently said for the 6th year running, it's the most common language ever, and it just goes to show how required it is to understand how to review applications in today's world. So, does anyone want to react about it here? This is my only pun of the presentation, so everyone else was very funny before me. This is the only one getting. So, you know, the web is changing and being innovated at amazing speeds. And we are having developers that are creating these amazing frameworks such as React and Angular, and ultimately, you know, anything like Ember and Vue. And they're being produced at quite a rapid rate, and developers are adopting these, abandoning these very quickly in today's world. And whilst we do have a lot of security protections from these amazing products that are being developed, they're also kind of, is anyone a penetration tester or does perform source code review here? Okay, a fair few people. So, I mean, if you've used any of the production or the commercial tools in the past, when you say, do you support Angular, they're like, it may come in a couple of years. You know, they're very slow to adopt these new frameworks, and that's unfortunate, but it's market demand. When not many people are using it, they're not going to put the money in to pay for it. So we just need to, whilst these technologies are helping improve the security posture of ultimately the client-side world and also server-side world, we need to be considerate of the pitfalls that happen inside these frameworks. There's also a fantastic blog by Gareth Hayes, who basically talks about abusing JavaScript frameworks to bypass HTML, or to bypass. And what this actually was is that there's a framework called Marvo.io, and it allows you to generate HTML on the fly, which is very good for developer innovation, but it ultimately allows you to inject cross-site scripting very easily. So, Marvo.io, yeah. So it's on the blog post, goes into all about, so there was a presentation at AppSec Europe about script gadgets, and he kind of extended on that about how you can abuse frameworks to ultimately execute JavaScript even when you have like strong CSP. So, and it was a very interesting presentation, sorry, blog post. I wouldn't, you know, it's not a negative spiel, it's a fantastic tool that you can use to build very, you know, amazing websites, but there are security problems when you start to utilize these things, which are kind of have a default aspect of being vulnerable. So, when we think about modern JavaScript analysis, does anyone here use Burp Suite? Burp Suite. So Burp Suite, is, as many of you know, is a very popular scanning tool, but when you start to look at things such as Angular, AngularJS, Vue, and React, and all these client-side frameworks, can't really rely on Burp to give you the answer. It can find template injection, but it misses a lot of the vulnerabilities. And from a security professional background, I've seen a lot of people just run Burp, look in local storage and go, I look for vulnerabilities. But security professionals really need to kind of embrace developer tools and work the same way they do. Because if I see one more pen test report that says open Burp Suite to do something, you can just go into the browser tab and go to the network tab and there's a kill command. I don't really want to deal with that anymore. So what I really kind of would recommend is, if you're doing penetration testing, is to, sorry, I saw his face again. Okay. So what I would recommend is for security professionals to ultimately embrace developer tools. And I'm going to show you a few examples today on how to do that. So when I talk about debug efficiently, I talk about if you're dealing with these client-side applications, you want to ultimately either know how to do it in the developer world through debugging on the console, or ultimately take it locally and debug that way. So I'm going to show that in a second. So what this talk is going to cover today is basically real-world examples, 3 examples from domain experts. And we're also going to talk about what kind of tools you would utilize if you're looking for issues in frameworks that might not be adopted by commercial tools, or may not be identified by Burp Suite. And also, I'm going to try and, I'm sure many of the developers here probably know these bugs, but many people don't from a security professional background. So the example 1 is, I have a disclaimer, I am about to show a video next, and Thomas, who found this issue, did give me the approval to use it, so I'm not just stealing his work. So the first example is Thomas Shepwell. I can never pronounce his Twitter handle, but it's Zenmens. I tried. And what he identified was cross-site scripting within inside a very popular Steam client. Well, Steam application that relates to Steam. So if anyone plays video games, you use Steam. So one of the edge cases with React, as many people know, is that it's safe to cross-site scripting in most cases. It does output encoding by design. It's very secure in that aspect. But unfortunately, there is a crux with when you include ahref, well, a prop inside an ahref. And if you include user input that way, you ultimately get cross-site scripting. But because of the way they were using things like WebSockets and so on, it wasn't very easy to capture all this information along the wire through Burp. So what he did, he had to utilize developer tools to ultimately identify security issues. And just to kind of also recap, this vulnerability, due to the way Steam has the Steam URI, similar to how you would do HTTPS. If you go and use like Slack and so on, they may have like a URI handler built for that platform. And this ultimately also allowed remote code execution due to this, the RCE, the Steam URI. So, I jumped way too. Okay, I jumped way too fast then. Okay, so let's just jump into the video, and I'm going to mute because it does have some. Okay. Bring it over to the other side, wherever this may be. So this one. Okay, that did not work. So 2 seconds. Okay, here we go. So, ice cream. Yes, it's ice cream. So essentially, let's just quickly jump to maybe 30 seconds. But the way this worked is, let's just give some background.
Can you full screen it?
Is it not full screen? Sorry.
No, not full.
Oh, that's as far as, unfortunately, as far as it's going to go. But it is online if you can't see it at the back. You can try and run up. But essentially, when you send messages within the client side of this application, it ultimately sends a message. And it's ultimately, as we'll see in a second, Thomas opens the browser console, and there's a few important things which are happening here. He's obviously opened the developer console, he's searching for the message called set message, and this is what allows you to send messages within inside the application. When he opens it, it's minified, so he unfortunately can't see the code until he beautifies it on the left-hand side. And now when he searches for the messages that he's intending to find, you can find them in a bit more, I guess, verbose way. So there's two functions here, and these are two different ways that you would send messages inside the application. And what you can do now is obviously add a debugger to each of these instances, so you can have full control of what the property is when it's being used on the client side. So when he now tries to send a message with the value is D, he's now obviously hit the debugger, and now we can go to the console and interact with that instance. And now as you can see, it's set message I, he's finding out what the value of I is. So what Thomas will do now is ultimately inject a JavaScript URI through BB code. Now, BB code is, think of it as a way of doing some kind of markdown representation of HTML. And what he's now going to do is ultimately include a JavaScript URI. Let's see if we can speed this up just a little bit. I don't want to go too.
Are you trying to like speed the video up?
Just, it's okay now. It's fine. So is this not full screen? Okay, it is full screen. But at the bottom, as you can see here, he's including a JavaScript URI with a colon, with a // and then a %0a, and then alert, obviously, to make the pop-up happen. There was some kind of client-side validation that was basically checking, or server-side validation that was checking for brackets. So obviously with ES6 implementation, you can use backspaces, and the backspaces would allow you to then do the XSS. And when he tries it, there's a heartbeat in the application, so it doesn't work on the first time until he reloads the application. But once you get towards the end, and obviously he sets it as BB markup, let's just play it, and the BB markup with the URL and the JavaScript URI. So when he refreshes the page and replays the message, can't get rid of the thing, ultimately now it will ultimately have the cross-site scripting. So he'll press D, or write a value, and then include that value to be what he expects, and then resumes it. And then ultimately, he will have this cross-site scripting. So,
does that affect anyone who's watching that channel?
Yes, anyone he sends the message to and they click the link. So in React, the only, obviously it would have been very good if, so let's just play it here again, and he plays the message, and then cross-site scripting will happen. So, then he clicks the link, and then XSS happens. So this would have happened to anyone who was messaging on the Steam app, and if they clicked the link, he would have been vulnerable. So what did we really see? So let's just break down a second. He opened the developer console and searched for the, he debugged the code, he looked into the code. He beautified it to make it more readable, which is very important. The problem with, obviously, client-side code is very hard to understand when you first start to look at it, so you have to do a bit of reverse engineering. And obviously, you overrided values and bypass security controls due to understanding the context of the application. So I'm not going to go into any more videos, that was the only one. Well, actually, there's two more, but they're mine. And the next example is Live Overflow. So Live Overflow is a very famous security researcher, and he hates pop-under ads, and I also hate pop-under ads. His YouTube is obviously jam-packed with fantastic information. I would highly recommend looking at his information. But what this allowed him to do was essentially find a way to take a look at this product. The pop-under product would be sold to people who are trying to do advertisement retainment. So you want a pop-under so you can retain the frame. And that's what he was ultimately selling. So he didn't want that to happen anymore, and had to figure out how it worked. So he ultimately did they had anti-debugging techniques to prevent you messing around in the console, but they're trivially bypassed through things like using proxies, where you can hook into functions. He also talks about deobfuscating the JavaScript, and I'll talk about some tools on how you can do that later. And of course, there were some weird browser quirks to make this work. So the reason why I'm showing you these examples is because if you've never done this before, the first example, the second example, and the third one I'm going to show you will give you the full context of understanding how to ultimately play around on the client side and find vulnerabilities. And now my third example, and Gareth Hayes, I mentioned his Marvo blog earlier, but he's one of my, I guess, in-house heroes when it comes to JavaScript security and security in general. He works on the Portsfigure team, and him like James Kettle and so on. They're very famous in the space. But he's done some extensive research into AngularJS. Does anyone write AngularJS in the past? Okay, a few people, very good. So everyone knows about the AngularJS sandbox bypasses who are working in Angular, and then you get a pen test report going, you're vulnerable to template injection, and you go, well, shows it. Oh wait, but you're using a version that has a sandbox escape. Even if I didn't have a version of the sandbox escape, it wouldn't be a problem. But what Gareth did, he really dug deep into the internals of the framework itself and looked into the features of what was trying to deploy the sandbox. Ultimately, the sandbox was merely a way to abstract developers away from the document object model. But what he did is he went through all these internals, he audited the framework code, and also did DOM manipulations and did prototype overwriting to change values that the internal features were utilizing. This obviously wasn't just Gareth Hayes' research, it was built on the work of giants like Jan Horn, Gabor Molnar, and a few other people, and Mario Hedrich. Ultimately, and they're the ones who did a lot of the research, but if you look at these two blog posts, you'll have a full context into the world of that realm. So, as this is an OWASP meetup, I really want to offer tools that are open source, and I don't want to talk about commercial, because I'm not trying to pitch you and sell you anything. So these tools that I'm showing today ultimately offer the ability to be used on any of your tools, but also, or if you're writing open source tools, you're going to get to the point where you can use these tools. So anyone who's a software engineer or a developer would know about data flow analysis. It's ultimately traversing through the application from a source and then going to an area such as a sink in data flow, and then you find the match, and then there's a source of taint. And Coverity Scan and LGTM ultimately offer these features for JavaScript. There may be more, but I couldn't find them, so if you can find them, I'll add them to the list. What I really want to go into a bit more detail today is tools that support areas of interest. So there are many different tools if you're writing in TypeScript, or if you're writing in ESLint, or if you're writing in JavaScript. There's many tools such as ESLint, JSHint, JLint, and you'll be able to use these to write rules if you're working on frameworks that are not currently supported in your aspects, and I'll go into a bit more detail into that soon. There's also Tarnish, and Tarnish is a fairly new release from Mandatory Programmer. It allows you to look into browser extensions. So you can just go to the store, throw in a browser extension, it'll take a look at the manifest and other things, and say, here are some problem locations you should investigate. Of course, there's people are always looking for low-hanging fruit, but you also need to know about security vulnerabilities in your organization. So there's also tools that will look for known security vulnerabilities. So when we talk about Retire.js, it's very popular in the pen testing world, but then you also have the inbuilt functionality from Yarn and NPM. Of course, GitHub automatically reports vulnerabilities, and if you're working with open source, Node.js in particular, you can use things like Snip. And if you're using like client-side projects, you can use like Audit.js. And of course, as I mentioned before about the deobfuscation techniques, there's a few things. Minify is an NPM package that you can ultimately use to minify things if you wish. There's also JStillery, and Clojure compiler is not really an obfuscator. It's technically used to optimize, but when you're optimizing, you're removing code that's not used, which is very useful to do debugging, or removing code you don't need to look at. So, and of course, if anyone's new, left my drink over there. If anyone's new to framework analysis itself, you have lots of tools that are used by developers to look at components of these frameworks. And when it goes to production, and you deploy it to production, you normally have the production mode set to true, especially in Angular. The funny thing here is, obviously, you control the world of the client side. It's your world, it's no one else's, and you're the master of its domain. So ultimately, You can remove that flag by just changing the variable or removing it from the source code, and then you can start to take a look. It's a very unclear picture on the side, but it will give you understanding into this world. And this kind of what introduced me to these, using these to the power, because when I first started to look into AngularJS many years ago, well, 4 years, I don't know, it was a long time ago now, 3 years ago maybe, I started to use Batarang when it came out. And Batarang is the client-side way of looking at components. But when I first started to look at this component, I viewed the source and I didn't see anything. I was like, what's going on? And ultimately, this is because everything gets generated at runtime. And if you view the source, all you're going to see are curly braces and be very confused, and ngIfs and ng-fors and so on. But what this allowed me to do was to take a look into the component and then see that there was an object related to a user, see that inside that user object there was an isAdmin feature, and then assign it to be from false to true. So we got to the point where I changed it, and it allowed me to see more of the application. This is obviously intended by design for single-page applications. You can't beat it. It's impossible to avoid it. But then if the server-side protections aren't there, then obviously you get fully compromised, which in this case, it was not deployed on the server, just the client-side, ng-show, ng-hide, and so on. So I would recommend taking a look at these tools if you've never done framework analysis, because it will give you the context you need and maybe do that mental mapping of mind to bring things together. So I mentioned before about when you're looking for known vulnerabilities. Obviously, there are so many. If you do an npm install or take a look at the actual flat map of an npm dependency list, it's huge. And it's very impossible to kind of track your vulnerabilities. And especially since we use npm, yarn, bower, and either client-side or node, we're getting to the point now where we kind of need to look for these vulnerabilities. But as you can see from the command list, we now have the ability to utilize these tools for npm audit, yarn audit, and if you're using bower, you can just use audit.js, or retire.js if you're using just purely client-side stuff and you don't have a package.json or a bower.json, and so on. And then obviously if you're using Node.js for open source applications, specifically open source unless you're paying for the enterprise, you could use the Snick Wizard to look for vulnerabilities. So ESLint has ultimately became my go-to tool when it comes to looking for vulnerabilities in JavaScript. As many of you probably know, ESLint is an open source JavaScript linting tool. And what linting tools do ultimately are going to traverse an abstract syntax tree and look for variable assignments or usage of insecure functions and so on. What you'll tend to see is that developers will never ship. They'll use Prettier, they'll use ESLint and use the autofix where possible. No one's going to ship with a bad linting report. It's just not going to happen. Well, some people may, but it's very unlikely. But obviously people tend to release with security vulnerabilities because you have to ship. So trying to be embedded into the world of JavaScript, especially in the developer world, you want to be part of these tools. And obviously you can break the build if it fails with githooks and so on. So as many of you may have looked at before, like the state of JS gave the full aspect that ESLint was the go-to tool. If anyone's using TypeScript, even the TypeScript rules by Microsoft are now being migrated into ESLint just due to the huge demand of usage. And if you're ever looking for vulnerabilities on the client side and or on Node.js and so on, there are an abundance of ESLint plugins that you can utilize for looking for known vulnerabilities. There's even some default configuration rules that you can use. And I'm going to go into a bit more detail about the one that I created, but it's still fairly rudimentary. It could definitely be improved, but at least it gives me a point of interest whenever I'm doing a penetration test or a source code review. So as you can see here, we have different plugins for like scan.js, which is for vanilla JavaScript, so ES, ECMAScript. You have ES plugin security, which is for Node.js and other aspects. Of course, the ESLint plugin for React has particular security rules, like don't use dangerously set in HTML. And it also has the AngularJS security rules that I created. There's also Vue and all the rest. So when I first started to look into AngularJS, obviously it's still, people say no one uses AngularJS anymore, but I do a lot of source code review and I can tell you people still use it a lot. So I had a problem, and I got to the point where I would be classed as, I guess, one of the better understanding of JavaScript compared to a few people in the organization that I work for. So they gave me a lot of the source code reviews and pen tests. And I ultimately had numerous pen tests where I had to look for the same type of vulnerabilities, and there was no tool at the time that would look for vulnerabilities for me. So I wrote my own linting rules to start at least giving me a baseline point of interest for these particular vulnerabilities. So I'll go into a bit more of a context of what you would do to create a rule. This is very arbitrary. But you would basically create a test that has a positive and false positive. Anyone who's writing unit tests knows this. I didn't start writing unit tests until a few years ago, so I was, anyway. And then you would basically walk the abstract syntax tree and identify your requirements, the things that you're looking for in the tree itself. And then you would create a rule from that output, and then you would make sure the test passes. So how would you create a rule? You would basically have a test fail and pass, and ultimately, as you can see here, we have a valid rule which is true and a valid rule which is false. This would fail in many cases if someone overwrote the value of SE to be something else, but we're not doing data flow analysis here, so it's kind of irrelevant. But obviously, you could also bypass the true rule by doing like 1 equals to 0 or 1 equals to 1, inside the value. So it's a bit arbitrary. The next, you would identify the requirements, and as you can see here, we have a member expression, which is normally 2 arguments, and you have the SC provider enabled, and then you'd want to take a look at the arguments of the call expression, which ultimately called it, and then if that is if that is identified to be true, then you would flag the rule. And of course, this would be an example of what that would look like in the code. We have a member expression, we're taking a look at the object name and the property name, and then we're taking a look at the arguments, and in this context, there will only be 1 argument, so grab the first argument, and then basically, if it's set to false, flag it as a problem. And of course, if anyone's ever looked at JuiceShop, JuiceShop is the OWASP JuiceShop, and it's the JavaScript go-to most vulnerable web application in the world.
There are stickers for it back here.
Oh, there's stickers for it. Great, I'm going to take one, that's for sure. And they have a Patreon now, so please donate generously. What you could do is then run it against some JavaScript code and make sure it's actually finding issues. And JuiceShop uses AngularJS as its front end. And as you can see here, the rules that the blog, I should have put it into blue, but appseco.com referenced the tool and showed that you could find it in the JuiceShop, which is obviously very good in that aspect. So I know I'm going to be I'll try and finish on time, but let's talk about some lesser-known security vulnerabilities in JavaScript. Many of you may know them, but we'll go into the context. So we're going to talk about DOM clobbering. So the browser has, at least the DOM specification is adapted and changed over the years, and there's different DOM specifications for things like PDF, XML, and so on. When we first started to have a document object model, we needed to have the way to ultimately have forms and the ability to overwrite values from the forms inside JavaScript. And the term actually DOM clobbering comes from gibbering.com, fact names. It says unsaved names for HTML controls. And this basically allows you to control elements from the form. So attributes that actually can be used to define JavaScript are IDs and actions, but also inside forms, you can define names. And in many cases, this can lead to cross-site scripting and also remote code execution if you're in a browser expression. So let's go into what DOM clobbering looks like. So as you can see from this code snippet, trying to make my screen a little bigger again. So as you can see from this code snippet, as the first value, we have a test, and that test value is defined with an ID of test. The same for foo and exists. But as I mentioned before, you can define attributes with the ID and also action. So if you search for, and it's also important to note that most of these vulnerabilities happen due to insecure comparisons on the client side, and also if you're going into a sync such as document.write and you control the property through DOM clobbering. So as you can see here, we have a test with a value and also an action which it says exists. So if we search for if value.action is not equal to undefined, which it won't be due to the DOM clobbering, it'll alert the DOM clobbering. And of course, value.foo is not a valid property which can be used for DOM clobbering, so it doesn't exist. The same for if value exists. Because value exists from the divider ID, it does exist, so it has DOM clobbering defined. But let's take a look at how this may work in a real life. And of course, there's forms as well. So when you look for the owner document of a form, it normally gives you the window document. But due to DOM clobbering, if we do form input name owner document, now when you search for the owner document, it's going to return the input, which is sometimes good for trying to escape out of sandboxes, what one of my friends, Alex, told me, which I haven't seen his code or his research, but that's what he mentioned. So let's go into a bit of what the exploit would look like in a real-world application, and this actually happened from CK Editor. So Mario Hedrich, who has a PhD in cross-site scripting, you can get them. And Cure53 is an amazing company, you should check them out. So Mario identified that CK Editor was vulnerable to cross-site scripting due to the way DOM clobbering, which led to cross-site scripting, through the way they were ultimately showing previews when you load an image. So what you could see here is that there's ultimately a document open, and we're doing a document.write, and we're doing a window.opener underscore CKEHTML to load. The exploit here is that because we can define the ID of CK Editor, and it's going into a document.write, it's going to include the normal href, but also our JavaScript code here, which is going to execute through the SVG. So let's take a look at this in practice and how it may look. And I understand that my screen is not very big, but we'll give it a go. As you can see here, yeah, I can put them online as well if you can't see it. So we have a document.write which takes that value of CK_HTML to load and then basically writes it to the DOM. But as you can see here, all we have at the moment is an ahref with a malicious JavaScript, but it has no way, and obviously we define the target underscore blank to make an opener. But the vulnerability here is that that value is undefined. And the value is undefined is because the ID has not been set. So we just need to define the ID to be what we intend it to be, which would be ID, which is the CK preview, or HTML to load. So now when we go back to the page and we refresh the page, we're going to have cross-site scripting, mainly due to the fact that DOM clobbering happened, and if the actual clobber happens where you're doing a document.write with the entire attribute of the ahref due to the ID definition. So it's very important when you're dealing with anything which is going into a sync that it can't be controlled, even if, yes?
How would I safely access owner document? Because you can't use the prototype of the document constructor because it has a different document constructor from a different document. So I don't know how it wouldn't be vulnerable to that. I get
it's purely a design issue. Probably.
Yeah, I can't find any way to actually not be vulnerable to that.
You're not. There's no way to get around it.
Yeah, for the owner document thing. That
Oh no, that's just an example.
Yeah, but for that specific one, you can't. Normally, you would just apply big capital D document.prototype object.get property descriptor for that, and then get the accessor for.
So what you could do is you could freeze the property, and you could clear out the entire property that you want to make sure isn't vulnerable to DOM clobbering, and then define your object, but then it still might be overwritten. I'm not entirely sure.
But normally you would pull from your own constructor, but it would be from another document. So usually you have to rely on that with the owner document specifically. So that like seems like a really big flaw. Just
I mean, that's I believe so. I mean, I don't really know in the true widespread prevention. I just know that it is a big problem when it comes to overwriting properties. So let's take a look at another real-world example. And I can close this one. So very recently, well, it wasn't recently, but in the world of technology, it's very recent. Travis Omangi of the Google Project Zero investigated various password managers for vulnerabilities. And LastPass was vulnerable to ultimately DOM clobbering, and due to the way it was checking to see if things existed and the way they process things. So take a look at this code. So if it's checking to see if undefined is not able to type of loose base matching. This obviously can be defined through DOM clobbering. And then it says return bxp that matches the base URL, which ultimately can be set through creating an ahref with the ID of base URL. And then what the LastPass extension did was basically, if these values matched, you could create a special form with that ID, and then send remote procedure calls to ultimately perform actions on the host, which ultimately led to remote code execution. And there was a lot of other features that was also vulnerable to this too. So the exploit here was essentially define the base property, and then create an exploit with the ID of loose matching, and then define the event form. So as you can see here, we're checking to make sure that this exists. And then all it's doing is calling the property of open attachment, and then adding the event data values, and then ultimately what it wants to run. Am I running low? 5 minutes, okay. I can finish in 5 minutes, it's okay. So, and then ultimately this allowed for a cal to pop up in this instance by running a back file through remote code execution. So it's very, obviously this just kind of gives the comparison. If you're doing falsy comparisons on a plugin, for an extension for example, you need to make sure that you're not just relying on that to perform actions, because it's ultimately a design flaw in the way the DOM was created. But it wasn't. It was for innovation. You needed to do it. So trade-off. And recently, so the next issue we're going to talk about, that was DOM clobbering. And if anyone wants me to go back over some of that, I can. Recently, my colleague looked into, in China, an IoT device that didn't really have a lot of storage or memory. So they created their own way of doing session management. And what they were doing is they were creating a session object, which then would be populated at some point. Can anyone spot the vulnerability while I talk? So we have basically a middleware that says must be authenticated, request, res, next, and then it basically checks if the cookies exist. And then we basically assign the cookie to a token value, and then we check to see if the token and the session exist with the token. We move to the next stage.
So you just give it the cookie before?
So, kind of, but if you just defined an invalid property, it's going to go no. So can anyone think of what you may be able to do to bypass these two checks on an object? So I only have 5 minutes, so I'll give the answer. So let's take a look at this comparison table. So if we have an invalid string, it's going to return false. If we have an empty string, also false. Then if we include constructor, it's true. If we include has own property, it's also true. So the reason why is that the objects inherit from the base object, the base properties. So it has prototypes. It has constructor has own property and is type of. And obviously, if you set test constructor equals to test constructor, that's true. So it's good. And basically, this allowed us to get full control of the application, while my colleague did. So obviously, the simple exploit would be to run against port 9000, add a token cookie, and then voila, we're in. So I have a quick example. That's only a few seconds long. So a minute. So as you can see here, we're using Express with a cookie parser. We're then creating the sessions object, and we have this middleware, which means, are we authenticated? It's doing exactly what we just displayed, and then we define it as a session object through the request cookies.token. So then when we go to the browser in a second, we're then going to basically come to that we're not authenticated. So, and obviously we want to get to you are authenticated. So if we refresh this, it says not authorized. But then we go to the console, we write, document.cookie equals to token constructor. And then when you refresh the page, it says you're authenticated. And I zoom in to be very dramatic, and then we end the video. So you're authenticated. Okay. So the way you would obviously fix this problem is don't use objects, use a map. Too long to read. And you can check to see if it has proto. But you can do has own property, and has own property checks to see if it only has objects, things that have been appended to the object, not from the base object.
Didn't use parentheses.
Oh, yeah, I wrote it manually. We'll do it live. So obviously, don't use authentication, don't roll your own, use something like Passport.js. It's very popular, very well tested. If you are rolling your own, which I would highly recommend don't do, use crypto and timing save equal, because it obviously does a secure comparison and it's not vulnerable to timing attacks. And other issues that I'm not going to talk about, but take a screenshot very quickly. But prototype pollution is very big in the Node.js world. Mass assignment is also very fun, and my colleague Amindir just spoke at Forward.js, and he talked about that on his presentation, which is at the bottom link. So in summary, the JavaScript world is changing very fast. We need to be able to debug efficiently and utilizing developer tools. It's very important that we need to embrace them. Don't rely on Burp Suite to find all the issues for you. You really need to dig deep in the world of JavaScript. Conduct regular code reviews, obviously write some rules, see if it finds issues, and then do metrics and so on. So measure and track your quality. Use ESLint and use npm audit for automating some of this stuff. Static analysis is fantastic if you can afford to pay for it, and obviously break your CI if things are bound. So that's my presentation. If you have any questions, I guess you can find it at the end.